Hello friends, welcome to engineering tutorial. So we'll continue our discussion related to thermal properties of materials on material science and engineering. So in this video we are going to discuss about thermal conduction. So basically it is about the mechanism through which heat is transferred from one point to another in various states of matter. So just a quick recap, we know that heat is basically the internal energy of an object which produces in us the sensation of hotness or coldness, and it is because of the molecular movement of any object. Okay, so there are three basic movements: translatory, rotatory and vibrational motion. So because of this, there is an internal energy in the object which is heat. But heat in itself is, we cannot define it. So in order to, for the transfer of heat to take place, there has to be a temperature difference. Okay, so heat basically flows from a higher temperature to a lower temperature. Okay, that is heat energy in transit, and the heat transfer, it continues as long as both the points they arrive at the same temperature. That is the basic principle, so that thermal equilibrium is established. Now how does this transfer of heat take place? And it's not that simple when it comes to different materials, because we know there are three important states of matter: solid, liquid and vapor or gaseous state. So each state has a particular mode of heat transfer. So there are three modes of heat transfer. One is conduction, which is basically in solids. Okay, then we have convection, which is for liquids and other fluids, and also in case of gases now, and radiation for long distance transmission of heat. So we'll discuss the three modes of heat transfer separately. In this video we are going to discuss about conduction, thermal conduction in detail. So basically, just to quickly explain the three modes of heat transfer, as I said, solids are usually heated by the process of conduction. Okay, basically the examples are heating of a metal rod or a metal pan or a stove. Then liquids and gases, they are heated by the process of convection. For example, boiling of water, the phenomena of generation of sea breeze and land breeze. And the process of radiation, it requires no intervening medium. In this case, it is the solids for conduction and liquids and gases for convection. But for radiation, as I said, long distance transmission of heat, there is no intervening medium. So the heat that we get from the sun, that is the process of radiation. Conduction and convection, they are comparatively slow as compared to radiation. So this is the general explanation. So if we go into detail, we'll discuss about thermal conduction first. So the next series of videos, it will be on thermal conduction. So thermal conduction is basically a process in which heat is transferred from one part of a body to another, basically from a higher temperature to a lower temperature, through intermolecular collisions without any actual flow of matter. The molecules, they do not get transferred, they just vibrate and collide with each other, and as a result of that, heat is transferred. Okay, so let us take a very basic example. Okay, let's say we have a metal rod. Okay, this is one end of the metal rod, this is the other end. Now obviously this metal rod is made up of molecules. which are closely packed. Let's say we heat one end of the metal rod. Obviously, the temperature in that end, it will increase slowly and steadily, and gradually the temperature will increase. So when that one particular end is heated, what happens? The molecules in those, that particular end, they get heated and they start vibrating with higher speed. The velocity of vibrations, the speed of vibrations, it increases. As a result of that, what happens is they start colliding with the neighboring molecules. Okay, they start colliding with the neighboring molecules, and as a result of that, a portion of that energy, that kinetic energy, is transferred to those molecules. So they also start getting heated and they also start vibrating with a higher speed. Again, they start colliding with their adjacent neighboring molecules, and again kinetic energy is transferred, vibrational energy is transferred, heat energy is transferred, and it goes on and on and on till the entire set of molecules, adjacent set of molecules, they start also vibrating and heat energy is transferred. So slowly and steadily heat is transferred from one end to the other and the entire metal rod gets heated. Okay, slowly it happens. One end is heated, the molecules, they start vibrating, okay, with higher vibrational energy, kinetic energy. They collide with the neighboring molecules, transfer of heat happens. Again they start colliding with the other adjacent set of neighboring molecules, and the transfer of energy goes on from one adjacent set to the other, okay, then to the third layer, then to the fourth layer. Slowly and gradually it happens, not all of a sudden, okay, and finally the entire rod gets heated, okay, from one end to the other, then finally the entire rod gets heated. This is the basic principle of thermal conduction of a metal rod or a metallic material through intermolecular collisions. Now here there is an interesting thing, okay, that the temperature of each section of the rod, it is not uniform. Here there is a important concept that the temperature of each section of the rod, it is not the same. For example, we know that heat energy is transferred from a higher temperature to a lower temperature. So obviously during the initial stage, when the rod is getting heated initially, obviously this region, the first region which is close to the heat source, it will be at a higher temperature. Yes, it will be at a higher temperature. Then this middle portion, let's say, it will be at a slightly lower temperature than TH, the extreme left side, because it is slightly farther away from the heat source. So let's call it some middle temperature, T subscript M, and this section, in this stage, no heat has no molecular collisions has reached this point, so we will call it the lower temperature side, T subscript L. So this is the high temperature side, or the high temperature section. This is the middle temperature section or the intermediate temperature section, and this is the low temperature section. Now as time progresses, the temperature of each section, it starts increasing. So slowly this point will be there, where heat reaches the extreme right section, there is some rise in temperature, but still this will be the point of highest temperature. This will be the point of intermediate or middle level temperature, which is lesser than TH, but this will be the lower side temperature. So here the middle temperature, it is lesser than the extreme left temperature, which is close to the heat source, but the middle temperature, it will be greater than the lower temperature, the right side, which is farther away, farthest from the heat source. This side is closest to the heat source, that's why higher temperature. Middle one is in the middle, so somewhere in the middle the temperature is. The low side temperature, which is the right side, it is farther away from the heat source. That's why there is some heat, there is some temperature there, but it is minimum. Okay, so heat transfer takes place through intermolecular collisions from one end to the other as the rod gets heated, and it does not happen all of a sudden, it happens slowly, steadily, gradually. Okay, and it is all because of the molecular collisions. Okay, solids, they are heated through conduction, through molecular movements, because of the vibrational energy, the greater amplitude vibrations of the the molecular movements, and as a result the average kinetic energy of the molecules that increases. And as these molecules they vibrate, they collide with the neighboring molecules, and there is energy sharing between them. Okay, and this goes on and on and on and on with each adjacent set of molecules as heat is transferred from one adjacent layer to the other till it reaches from one end to the other, till the entire rod gets heated. Okay, this is the basic principle of thermal conduction. Now here the interesting thing is that here the molecules, they have not traveled from this point to here. Okay, see, this is the initial state of the metal rod. This is the first set of molecules, and this is 2, 3, 4, 5. This is the fifth layer. Here the first layer has not traveled to this position. They have just undergone vibrations, to and fro vibrations. Their position has not changed. I mean, they have not, the first layer has not moved to the fifth layer. Okay, they have just, because of the vibrations, there is some space between them, but they have not overall changed their position from one side to the other. It is just because of the vibrations and without any actual movement of the molecules. See, they always attain the equilibrium position. We have discussed that whenever vibration happens, it happens about certain mean position, okay, equilibrium position. So the molecules will naturally return back to their equilibrium position when the heat is removed and the metal rod, it cools down. But for the process of heating, they have just undergone vibration. Okay, the first layer has not moved to the second layer, the second layer has not moved to the third layer, the third layer has not, they are there in that position, adjacent layer, they are present in that particular position. They are just vibrating about a certain equilibrium position. Okay, so when the vibrations occur, they collide with the neighboring molecules, and as a result, because of these collisions, they transfer a certain portion of their kinetic energy to the other adjacent layer, and this happens till the entire rod gets heated. Now suppose the heat source is removed, this is, the rod is fully heated. Now suppose we remove the heat source, what will happen? The reverse thing will happen. Slowly we will go in reverse, this position, then this position, then this, then finally this. They will return back to their original state, the equilibrium position. So here there is no flow of molecules from one point to another. Okay, it is just because of the vibrations and collisions, the heat energy is transferred from one point to another. Okay, so this is the basic concept of thermal conduction. Okay,